or as you also heard during the midterm presentation, were the floating arm trebuchet and the floating axle King Arthur. So over here we had our acrylic models. So we decided to use acrylic to model our two designs and then to later test them against one another. Now this was probably one of the biggest learning experiences during our project. Laser cutting has a lot of flaws, and as a lot of the other groups have explained, for example, I know the gumball machine noticed that the sizing was different when you cut things. We can only really use acrylic to model. That's why we limited it to strictly this part of our design and isn't seen anywhere else. So we decided to first do the floating arm, which was done by myself and Matt Healy. And the way it works is it drops the counterweight vertically from the center of the machine, and as it falls, it pivots around this back wheel. Now, once the arm reaches its horizontal position, 90 degrees to the direction of the counterweight, it begins to pivot on this wheel, therefore allowing it to roll forward and whip much farther than a regular trebuchet would. Now, our second design was the King Arthur floating axle trebuchet. Now, this trebuchet features its double pendulum motion. So the counterweight is first dropped from a release height. As it's dropped, it pivots around the cart to this first pivot point, which acts as the first pendulum. Then once it reaches below the track, the cart begins to roll forward, and it begins to pivot around the second point, allowing the arm to once again swing forward and release the projectile. When we competed these two, we found this one to be far more efficient than the floating arm trebuchet. Then, using this, we decided what were our flaws in this design, how do we fix it, and what do we do to find out what distances we can expect because we want to win. So our next step in our process was to create some kinetic modeling. So over on Matthew's laptop over there, we had some kinetic modeling software that we found online, and we'll have time to see it after, only because we want to get through this part of the presentation first.
We're unfortunately limited because we don't have displays, so feel free to play with both of those computers afterwards.
We'll leave time to play with everything. We did some kinetic modeling. Unfortunately, couldn't obtain software that gave us a lot of numerical answers, but with this software, well, if Matt wants to explain.
Right. This is the free version of the real software, so it's pretty limited.